Alrighty. Hi, everyone. Thank you guys for coming to this session. I really appreciate it because I know that this is late. You guys are kind of skipping dinner right now. We're going to dive right in because we have a lot of content to present in a short amount of time. This is using Alexa to reach millions of new customers by developing for screens. My name is Cami Williams, and I'm an Alexa evangelist. We also have Steve Arkonovich. He's one of our stellar skill builders. Also want to shout out in the room Arun. He's our senior program manager, and we have Jamie as well, our senior UX designer. So if you guys have any questions after, definitely go to them and not me because I'm tired. Quick layout of what we're going to go over today. We're going to talk a little bit about our multimodal vision on Alexa. Then we're going to dive into the Alexa presentation language. That is the meat of what we're going to discuss today. We're going to show you a Hello World example using the Alexa presentation language. Building a custom layout. We're also going to showcase Steve's skill, Big Sky. We're going to go over adaptive rendering with APL, and then finally we're going to go over some unique multimodal features that marry your voice user interface with your graphical user interface, your VUI and your GUI. So if that sounds good, let's dive right in. So this is one of my favorite slides to present. If you've been to any other Alexa breakout sessions today, you've probably seen this slide. It's pretty exhaustive. But essentially, what we like to depict here is that every 10 years or so, there's a major disruption in technology. First, it was characters appearing on a screen. Then we have our graphical user interface coming into view. The idea of direct manipulation was introduced. Finally, we move on to web. Everything started to go online. From web, we moved into mobile. Everything online had to become mobile compatible. And this introduced new ideas and features such as incorporating physics into your technology. If you're zooming in, you're pinching and expanding with your fingers. Now it's something that we know how to do. Even little kids know how to do it, which is insane, seeing them be really good at Angry Birds. And yeah, it's crazy. But now we're starting to see a new major disruption in tech, and that is the incorporation of voice. Obviously, right now, it's very, very trendy to be into artificial intelligence and machine learning, but the way we personalize that is through voice. And as with all of these technologies, we have to give a nod to its predecessors. So the best way to see that is with multimodal. So our first stab at multimodal was with the Echo Show. We introduced that about 2 years ago, and then the Echo Spot we introduced last year. And with this, for our developers, we offered some display-directed templates. And these templates were standard across screens. We promised that they would scale according to the Echo device that they were invoked on. But essentially here, we kind of gave our developers some limitations. There wasn't a lot of creativity that could jump into this. This is an example of what Big Sky, Steve's skill, looked like with the display templates. And we knew that we needed to take a step further. Alexa was growing. We saw her starting to enter into new spaces. And we started to realize as well that our customers loved interacting with multimodal devices as well. So with skills, we knew that they wanted complementary visual content. Whatever Alexa said, the visual needed to complement that. We also saw that they simplified interactions. People knew how to interact with Alexa even deeper because they could see on the screen different things that they could say next. There are also ambient experiences. This you would see in the home screen. On the Echo Show, you can see she would say, try and say something like this. So again, furthering that interaction. And then finally, just overall a richer media experience. If I invoked a skill that had some displays in it, I would get more information that wasn't necessarily crucial to what I asked Alexa for originally, but just, again, emphasized what I could do. So with all this, we decided to expand our vision as a whole. So we have a ton of new multimodal devices. We just announced the Echo Show 2nd generation, which just features a larger screen. We also have the Fire TV Cube, which allows all of your TVs to then become Alexa-enabled. We have Fire tablets, and again, the original Echo Show and Echo Spot. And this is only going to continue to grow. But for our developers, this got a little tricky. We expanded our multimodal vision for our customers, but not necessarily for our developers right away. So this is what, again, it looked like with our display templates. We had limited reach, obviously, because they were only according to what we were able to develop for landscape and round devices. We also, again, had predefined layouts and formatting. You couldn't really work outside of these bounds at all. And then finally, in general, it's difficult to adapt your experience according to the medium. Obviously, if you're on an Echo Show, you would interact with it differently than you would your Fire TV. So now this is the new experience. This is Big Sky using the Alexa presentation language, and it looks really awesome. You can see it's totally customizable, and you can also tailor your layouts according to the medium. So again, this is all built with the Alexa presentation language. A couple key factors that we wanted to incorporate here were that it was totally customizable. You can bring your own brand now to your Alexa-enabled devices. So before, again, we were restrictive to our developers, and it all basically looked the same. Now you, as the developer, can completely customize it. Furthermore, you can adapt it to different device shapes and characteristics. Again, you can see you would interact with an Echo Spot differently from your Fire TV, so now you can adapt your displays accordingly. It's also guaranteed to be available on all Alexa-enabled multimodal devices. So you can see we have Fire TV experience, Echo Show, Echo Spot, and more devices to come. And we also offer unique multimodal features. Again, features that marry your VUI and your GUI. So an example of this is with commands.
Amazon, open daily travel.
Gouda, sharp cheddar, blue, brie, cheddar, parm.
So you can see here, Alexa is interacting with the screen and the GUI at the same time. And because this generated a new team, we also got some new puppies, but that doesn't really benefit you guys. But it's great for us. So let's see that in action right now. I'm going to hand it over to Steve, and he's going to demo Big Sky.
OK, yeah. So as Cami said, I'm Steve. I developed Big Sky, and recently I completely revamped it with the Alexa presentation language. You saw what it looked like before. And now let's take a look at what it looks like now with a live demo. Amazon, open Big Sky.
Can you switch our thing?
Currently, it's...
Oh, it's not switching?
It is not.
Are you pressing take?
I am pressing take.
It's just not taking.
I'm pressing HDMI 2 and take.
Are you sure there's not a no take button? No, that's it.
Play funky music.
Excuse me. That's odd.
Nope, it is on, and it's plugged in. Hey!
Oh, there it is. OK, great. It's going to be even better now after the anticipation is built up, I hope. Alexa, open Big Sky. Nope. Amazon, open Big Sky.
Try it again.
Let's try it again. Amazon, open Big Sky.
Currently, it's 52 degrees with light rain.
OK, this must be set
that way for the hour.
for Seattle.
You can expect light rain,
it's actually
turning
nice
to
outside.
rain by morning.
OK, so one thing to notice about this is that, as Cami said, that's a completely custom template. There is nothing in the old display templates that would allow you to create a visual presentation like that. Another thing I wanted to point out is if I had let Alexa keep talking, you would have seen another display screen come up to complement the visual output. So this is a really cool feature of APL that was introduced called paging that allows you to present several screens for the same intent. So you can get a lot of information in a way that complements the visual in the auditory output, because you might not want Alexa to say all of this stuff. OK, so now let's see what it looks like on a Spot. Echo. Open Big Sky.
Currently, it's 52 degrees with light rain, remaining that way for the hour. Tonight.
OK, great. So you can see, again, a completely different APL document, completely different layout that is appropriate for the smaller form factor of the Echo Spot screen. Another way, so you could adapt the APL to the different form factors of the devices. Another way that this is adapted is the paging element that I talked about that you saw on the show is also here on the Spot. But because the screen is much smaller, it wouldn't make any sense to put all of that information on one Spot screen. So it's sort of spread out among many different screens. So APL really does allow you to adapt and customize the visual experience to the different devices. All right, and now Cammy's going to talk a little bit about how that's possible.
Yes, and I'm going to switch by hitting that. Woohoo! So it's worthwhile noting there, too, you saw that Steve incorporated info circles on each of the different layouts for the devices. Those are things that you can actually share and host with the community, which is really cool. Let's talk a little bit about how a multimodal skill actually works. So if you were to ask Alexa for, I'm going to mute, OK, I'm going to mute that just in case. If you were to ask Alexa for the weather from Big Sky, that utterance would be sent up to the Alexa service. We would do automatic speech recognition and natural language understanding and push it through the actual Skills Kit API. All of that is going to be mapped to an intent and formulated into a response that's sent to your Lambda service. And that would point to a function within that service. As with any function, you would also have variables, and those we call slots. In that function, you would formulate Alexa's response, how she would respond back. That would be comprised of an output speech, a rendered document, an APL document that you would send back to the device, and any commands that would follow that document. And we'll talk a little bit about commands later. So then that is then pushed to the device. Everything is inflated, and Alexa begins to speak. It's fairly simple, and there are different things that APL is actually comprised of. So the first is components. Components are basically just different things you can put onto your APL document. APL is written in JSON, and so you would just set the type, for example, to text, and then have any attributes associated to that. Another thing your APL document can be comprised of is styles. These are synonymous to CSS styles in a way that is renderable for APL. But essentially, if you wanted to create a style, you could do that. Resources are essentially your global variables, so they're things that you can define and then utilize within your main template. This can be colors, dimensions, strings, booleans. Anything you want to globalize within your template is a resource. Following that is layouts. These are composite components, so something like info circle is a layout. They're essentially different layouts that you can create and utilize throughout your document. We also have conditions. These can choose to inflate things based upon the condition, and these are called when clauses. So if I wanted to show specific things on my Echo Show versus my Echo Spot, that's something that I can define within my APL document or in my skill code. And then finally, commands. These are messages sent to your actual APL document that can change the visual or audio presentation of your skill. So an example command we saw earlier when Alexa was highlighting the list item that she was on, that command is called speak list. So with all that in mind, let's do a Hello World sample so you guys can get a taste of what APL looks like. In this Hello World sample, we're going to do a couple things. The first thing is we're going to create a basic APL document. Then we're going to add that document to our skill. We're going to enable the APL interface. We're going to detect APL support at runtime. And then finally, we're going to render the APL document. So if that all sounds good, let's get to coding. I'm going to switch back if I can. Let's see, wait. There we go. OK, awesome. So this is our developer portal. How many of you have developed a skill before? Let's just read the room. OK, awesome, good, a majority of you. For those of you who haven't, this is where you would start to build your skill. On the left, you can see we have a menu of our intents. These are, again, things that a user can actually request for using an utterance and receive a response back from Alexa. So in our case, we have one intent, it's hello intent, and you would say hello reinvent. If we scroll down and click on interfaces, these are different things you can enable within your skill. So you can see we have audio player if we're going to create some sort of audio player skill, like a podcast skill or something, and it's intuitively named for each. But if you scroll all the way down, you can see I enabled Alexa presentation language. This is the first thing you will do if you want to enable multimodal support via APL in your skill. So once that's done, I set the endpoint in my skill. This just points to a Lambda service. You can also do HTTP endpoint. We also have this tab. I have to log in again, that shows our intent history. And then finally, if you click on display, you'll see this authoring tool appear. This is the APL authoring tool. Note that this is not a simulator, but this is just a way where you can author different templates. It's pretty intuitively named. If you're familiar with our old display directives, we also offer these in APL as well. If you just hover over them, you can see they're similar to body templates and list templates. But for me, I'm going to start from scratch. And I'll have to log in again, probably. Let me just quickly refresh. Hey, here we go. All right, so this is the layout I would see if I want to create a new APL document from scratch. This is the view that I like to call layout view. You can see up here I can toggle between my different devices and hubs. So I have a small round hub that's synonymous to an Echo Spot, and then it just goes up accordingly all the way up to a TV. You can also see that there is a preview on device feature. So these are all of the devices I have associated to my developer account. So I can easily just push whatever I have to one of my Echo devices, and then it will appear. This is nice because you don't have to go through the turns in your skill to get to the screen that you want to preview. You can just do that right off the bat. You can see I also have a hierarchical view, but this view I'm going to actually toggle to the straight-up code view because I like to look at code. So this is what an empty APL template looks like. You can see at the top we have type APL. We also have a version number. We have a theme. The theme is defaulted to dark. Imports are just things that you would import and utilize later. For example, if Steven hosted his info circles layout, I could import that into my APL document and utilize that throughout my main template. Resources, again, are the global variables. Styles and layouts we explained earlier. But I am going to go into my skill code and then copy a Hello World demo and show you guys really quick. So I know it's small, but hang tight. Oops. OK. So you can see I have Hello World appearing on screen. And if I toggle the different hubs, you can see how it looks on each of the different devices. But let's look at the actual code for now. So first, I define my own style. This style just kind of styles the Hello World text for me. So I set the font weight, font size, text-align center, text-align vertical center, and I set the color. So if I change this style to blue, let's say, you can see now Hello World is blue. I'll change it back to green. Scrolling down, first I have parameters that read in a variable called payload. This is directly associated to my data source, and this is something that is sent alongside the APL document. So if I am in my skill code and I want to send some sort of information from my skill logic to my display, I would do so in the data JSON, and that would be accessible via the payload parameter. Next, you can see I have a frame. A frame is a component that allows me to specify a background color. So if I change this to cyan, even though that's really ugly, you can see that that is updated directly. And then finally, I have that container, which would just contain other components, and then the text that has that style. You can see the actual value of the text, though, references the payload. And that I would just utilize right here. So if I change this to say, hello reInvent, now it appears here. So I could easily make some sort of web service call and push the information in the response of that call to my display, and I would append that in the data JSON. I'll change this back to hello world. In the actual code, in my actual skill code, You can see I am in my launch request handler here, and I have this variable skill response that just formulates my response according to the demo that we're currently at. So in my show demo 1 hello world, I have named my actual APL document my document, and that just references the code that we just saw. I also have a my data sources document that has the data source information. And then we add a new directive to our response builder. So in this case, it is our render document directive. I have a token associated to that, just so that way I could easily match that up with any commands that I want to send as well. You assign the document property to the my document that you want to render, and then the data sources accordingly. And then you send the response. So let's see what that looks like on our devices. That one is Amazon. Amazon, open demo drama.
Hello world.
Ah, exciting. And then we do echo, open demo drama.
Hello world.
Wow. And then we have this cool experimental looking device. Ooh. Alexa, open demo drama.
Hello world.
Wow, it works on all of them as promised. So again, let me just mute all these really quick. With APL, if you build a skill in APL, we allow that to be accessible across varying devices. So if you think of this on a broader scale, you can see, again, Alexa entering different parts of your home for our customers, and you can utilize these different mediums with APL to create different experiences for each. So let's break down what we just saw. Again, this is the screen that we just rendered. There is a parent container around a text component. The hierarchy is pretty intuitive. If something is contained in something, it is a child. And so you would just input that directly into the JSON. It's pretty standard. But let's look at something a little bit more complicated. I'm going to hand it back over to Steve, and he's going to show you how his Big Sky main template is broken down.
OK. Yeah, so I'm just going to go into a slightly more complicated example. First show it on the screen, and then get into the APL to see how that was built. As Cami said, APL is hierarchical. So the entire visual layout of Big Sky is contained in a main container that contains all of the other elements as children. Going down a little bit, a container in APL is just a sort of Flexbox style component that importantly can hold other APL components. So in the main container here, for example, you see a text component. In this case, it's just a little text display of the time. And on the left-hand side, another container, which is inside of the main container. And that sort of creates a nice visual division of the screen. And then inside of that container, on the left, there are some more APL components. So you should really be getting the idea that it is sort of a hierarchical setup. So inside of that container are some more APL components. For example, an image, that little weather icon, a text showing the weather summary, and a frame that Cami already talked about. And again, the cool thing about frames is that they can take a background color, even a transparency. And so you get this nice sort of semi-transparent image. OK. On the right-hand side of the screen, things look a lot different. But in fact, what's going on is not different at all under the hood. These are info circles. These are not sort of standard pieces of APL, right? They're not standard APL components. But one of the really powerful features of APL is that you can create your own complex compound components, define them in a layout, and then use them and reuse them throughout your skill or across other skills. So let's take a look at the actual APL document to see how that display was generated. OK. So I'm going to take the actual APL from here, put it into the visual editor. That just needs a little bit of something to display before it looks correct. So here's the data that is bound to the APL document. Again, it's a little bit more complicated, and this I think is set for a large hub. Okay, and so let's just take a look at that before we get into the actual APL. So there it is, a slightly more complicated APL display. So if we look at those components that I talked about earlier, I said that the entire visual display is held within a main container, and you can see it here immediately following the main template. It's a container, and the way you declare a container is you just declare the type, say container, and the container will hold other APL elements. For example, an image. If we move back down, that would be a background image. You see here the type text component is declared, and that gives us the current time. And scrolling down a little bit further, if you remember, to the left-hand side of the screen, there was a subcontainer that had that transparent background, and that's defined right here with a frame with a certain color and transparency. So it's all pretty straightforward. Now, on the right-hand side of the screen, there are all those circles that have been mentioned, info circles. Again, those aren't part of APL when it comes to you, but you can see that in the actual APL document, you use them just as you would use any sort of native APL component. You simply declare them under the type. You say info circle. You provide the parameters you want, for example, the color and the size, and voila, they would appear in the document. Again, those don't come with APL. One of the powerful features of APL is that you can create these yourself. So if we go back up to the top of the APL document, under the layout section, you can see that this is where I define what an info circle is under the layouts. I assign it some parameters in this array, and then I won't get into this. The actual info circle itself is quite a complicated thing. It contains 11 or 12 or 13 other APL components. But once it's defined and declared up in the layout section, you can use it just like any other piece of APL. Okay. Now we're going to talk a little bit about another feature of APL, adaptive rendering. I think Cammy's going to do that.
Okay, cool. Let me
or part of it.
Switch back. Cool. Awesome. Yeah, so let's get in a little bit to adaptive rendering. So we've hinted at it before, but we have a lot of different mediums that you can develop for. And as a developer, you might be thinking, OK, now I have APL. Now I've expanded my reach. How do I assure that I am able to capture every experience? Well, first thing at baseline, you want to make sure that you implement your skill in a voice-first approach. Our devices started as speakers, something we call headless devices, devices without a screen. And a majority of our customers have these. And so you want your skill to be able to reach them just as much as everyone else. And so it needs to be voice-first. Moving on, we also have devices that are smart screens. These are our Echo Shows and Echo Spots, essentially devices that our customers intuitively bought to act as a smart assistant, like Alexa. And then finally, TVs. This is something that a lot of customers have. The interaction with the TV is pretty universal, but incorporating Alexa into it kind of not only expands what the TV is able to do, but there might be a little bit of a disconnect when customers interact with it. They might not treat it as they would a smart screen hub. So you also want to keep that experience in mind. And of course, this is projected to expand. We're seeing Alexa appear in now a lot of kitchen appliances. We have Alexa Automotive. And this is just going to continue to grow. We believe that Alexa will be everywhere. And so for you as the developer, the best way to encapsulate all of these is with APL. For now, when you create your skills, tailor your experiences according to what is in the authoring tool. We have the small round hub, the medium landscape hub, large landscape hub, and a TV landscape extra large. You should utilize those. The best way to access those characteristics is with our viewport. So you get viewport information, essentially information about the device in your skill code. This is accessible in the request, and it contains a varying set of characteristics that you can utilize to your advantage. We have width and height, DPI, dots per pixel, dots per inch, sorry, the shape of the viewport, the shape of the device, and then finally, if it's horizontal, landscape, vertical, or if it is round. And then we have different inputs that it can take in. Is it touch? Does it use a remote to click? Varying things like that. So again, this information is a part of the skill request, but we offer it in a nice, packaged, beautiful, neat, accessible way in the SDK, so you can utilize that information within your skill. So switching it back over to Steve, he is going to demo how he utilizes the viewport in his skill Lambda.
Yeah, OK. So there's a couple ways that you can, as Cami said, you can adapt the APL for your skill. And the first way is in the skill code itself, the skill Lambda. So I'm just going to show you what that looks like. So the first thing to see how you would do that is probably to make sense to start with the skill request. So it seems like almost everyone here has built a skill, so this might seem familiar to you. The part that might not seem familiar is the viewport blob in the JSON, which, as Cami said, gives you a lot of information about the device that the user is employing to invoke the skill on. For example, it tells you about the width and pixel height of the device, the density, whether you can interact with it through touch or a keyboard or remote control. So just a lot of information that's given to you in the skill request. OK, so then you can take that information in the skill request. And when you look at the actual skill code, you can, let's find the actual skill code. There it is. You can declare, for example, what APL document you want to send to the device depending on the device characteristics. Now, as Cami said, if you use the SDK, there's a really convenient way of sort of mapping sets of device characteristics to what are called device viewport profiles. And you can see that there are several viewport profiles here. So in this handler, right, it says, well, look, if the user is using a small round hub, basically a spot, then I want to send this particular APL document. If they're using a different device, like an Echo Show, then I want to send a different APL document. And so you can adapt the APL document depending on the needs and the characteristics of the device itself. And one other really cool feature is that these viewport profiles that are provided to you as a sort of a convenience method in the SDK are the very ones that show up in the visual editor, right? So let me see what's showing here, right? So you can see what the APL looks like depending on what device you're using, like a large hub, that's the new generation Echo Show, or a small hub, it looks like that, which is a really good argument to adapt the APL and send the appropriate document to the device. Otherwise, it doesn't look so good. OK, so that's how you can use adaptive rendering using your skill Lambda. Let me switch back to this, I think. Actually, I don't want to switch back to that. Another way you can use adaptive rendering is in the APL document itself. So actually, and you do this by using when clauses. And when clauses just sort of state the conditions under which you want certain parts of the APL to be displayed or not displayed. And Big Sky uses when clauses for adaptive rendering a lot. So let me see if I can, find this. So what I'm going to do is just show you another Big Sky APL document. And we'll go back here and put it into the, whoops. Yeah, that looks good. And grab the data that will be bound to the APL document. OK, great. So I think this is the display that comes up if you ask for the hourly weather forecast. And one thing you can notice is that it's displaying a 30% chance of rain and a certain percentage of cloud cover. And that's great if it's going to rain and if it's cloudy. But if the user asks for the weather on a perfectly sunny day and there's no chance of rain and there's no clouds, you might actually not want that to show up in the display. So you can use a when clause. And let's go to the actual APL document here. And you can see what should be familiar, the info circles. There's a bunch of them. And if you look at the one that displays the precipitation probability, just like before, it's declared, you declare the type info circle, then it shows up. But here you can also see that the when clause says, look, when there's a 1 or greater % chance of probability of rain, then show this part of the APL. If there's not a chance of rain, don't show this part of the APL. So if we go to the JSON and we change the data, so we say, look, the precipitation probability isn't 30%, now it's 0%, you'll see that this sort of disappears from the APL document altogether. And then if you add it, it pops back again. So yeah, so that's kind of cool. So it's really a really powerful feature of APL that you can decide what to display at runtime depending on the data that shows up, right, that's bound to the document. So you can completely adapt your document at runtime depending on your needs at the time. So that's super cool. There's another way of adapting the APL, and that's through touch. Cammy's going to talk about that.
Yes. Let me switch back. Cool. Yeah, so just to summarize what Steve said, there are a lot of different ways that you can utilize when clauses to your advantage. You can choose to expand or hide different components based upon the different viewport characteristics, or just in general various characteristics that you can set. So for example, Steve could send something in his data source and create a condition behind that and utilize that as well. You're not just bound to the viewport for your when clauses. Cool. So now let's get into touch. Touch is something that people will intuitively do with your smart hubs. But with TV, it's a little bit different. Obviously, most of our customers wouldn't just go up and tap on their TV to perform a touch command. They would utilize their remote for clicking. So we created a component called Touch Wrapper, and Touch Wrapper kind of encapsulates everything that you need to do for interacting with the screen. So you can see here, this is an example of a Touch Wrapper component. It's just type Touch Wrapper. And when a user selects something that is within the Touch Wrapper, you can see we would send arguments. In this case, the arguments that are sent are next item and then an identifier of that item. So in this case, you can imagine if they're selecting something on a list, it would say, I want to perform the command next item, and the next item would be the next item according to that item identifier. This request is sent to your skill similarly as a voice command would be sent, but it is called an APL user event. And within that user event request, you can see the arguments are right there. That data binding happens within the request, and so you're sent that, and you can utilize that in your skill code as you would a normal intent request. The way that looks here is if the user touches something on the screen or clicks something with their remote, that request is sent up to the Alexa service, again, just as a normal intent request would be sent, except it is a user event. And so you would essentially, in your can handle, create a condition in order to be able to handle that user event. But then the formulation of the output speech and the render document execute command is all exactly the same. So you essentially just need to create an umbrella for user events that they might be able to select, and then it's handled the same way. And that is where it happens. So really quick before we move on, something that you want to keep in mind with all of your user events is with every touch action, there also needs to be an equal voice action. Again, this is promoting voice first, but if a user is able to touch or interact with something on the screen, they should also be able to do so with voice. So we have a couple built-in intents that you can use that is scrolling up, scrolling down, next, and so on and so forth. And those will all intuitively happen with your screen device, especially as we get into pagers, like how Steve showed you in his demo before. But it's just a design tip that will help your skill pass certification. If there is a button on your screen, the user needs to be able to say, hit the button, or whatever the button's action would be. So again, we're going to lead that into unique multimodal features. We kind of talked about that a little bit with touch, how we see the interaction with that, VUI and GUI. But a bulk of this is done through APL commands. So I've already talked a little bit about commands, but essentially they're messages sent after your document is rendered to be able to manipulate that document in some way. So this can be changing the video or audio presentation of the content on the screen. But again, they are sent after the document is rendered. So if you have some sort of token or component ID and you send a command that is utilized for that specific token or component ID, then it will be inflated and appear on screen after it is rendered. So we saw this with your text synchronizing with voice on screen. So there is a command called speak item. And this would just say, sync what Alexa says to what is on screen. You can also toggle for it to highlight as Alexa says different things. And speak list is also intuitively named. She would just speak the current item in the list, and that would highlight on screen as she says so. So let's see a quick demo of that. I am going to switch over to code view. Cool. OK, so let me grab the document. I'll just show you right here because it's expanded and you can see it a little bit better. But you can see, again, we're back into this old Hello World-esque view. And within our text component, you can see we have an ID. This ID is so that way we can match the command to the component. So it's just a mapping feature. But then we have in our text attribute, we are reading from a property in our data source. We also have a speech attribute now, again, reading from a property in our data source. And then we have the style. So I'll pick that up, and I'll put it in the authoring tool so you can see it. And there we go. So now, because we have nothing in our data.json, you can just see it says payload. It's waiting for that information. In our data source, we have something called a transformer. So you can see the property. We have primary text. It's just knock, knock, who's there? Alexa, Alexa, who? Alexa. Haha, funny. Arun made that joke. But then when it's read in the actual document, the first thing it does is look at the transformer. The transformer essentially says, take primary text and convert it to speech. We use a transformer so that way we assure that whatever appears on screen matches what Alexa says. We don't want you, the developer, to be responsible for keeping track of those two variables, so the transformer just has one ultimate source for both. So I copy that. I put it in my data.json. You can see it appear here. But then when we actually show it in action, you'll see as Alexa says it, the text is highlighted. And the way that is done is with the speak item command here. So you can see our document is first rendered. That's sent first. We use the my document and data sources that we just saw. And then after the document is rendered, we send the command. So in this case, we utilize the same token, showing that the document and the command should go in sync together. And then we have the command speak item, pointing to the component ID joke text. Again, that's saying this command applies to this component. And then there are various attributes we can also send with speak item. In this case, I just say I want to highlight line by line. You can find all these properties, though, in our APL documentation. So once this is sent to our device, we can see how it runs. Amazon, ask demo drama to joke.
Knock, knock. Who's there? Alexa. Alexa who? Alexa.
And voila. So you can see how we could utilize this effectively in interactive stories or just reading the news or some large block of text. We found that especially kids like to interact with skills this way because they like to follow along with Alexa, repeat what she has to say. So this is something that we got from our developer community, and we decided to prioritize and release in our public beta. And that's the demo video, but the demo worked, so we can skip it. Another component is something called Pager. Again, we saw that earlier with Steve's demo. But it's essentially a way for you to send multiple items to a single document. It's essentially a slideshow. So you can send a command alongside of it to auto-scroll along with the document, or you can just say, Alexa, swipe, and she would do that. But this Pager component, again, can sync to voice. I mentioned earlier we have some built-in intents, so one would be Alexa next or Alexa previous. This would be a way where you can easily interact with your device from far away versus having to go up and touch. So we promote, if you're going to use slideshow, you have to incorporate those intents as well. The commands, again, as I mentioned, you can do auto page and set page, so you can have it automatically scroll, or you can set the page that it's currently on with that. And we have more unique components and commands to come. Again, APL is in private beta, so essentially stay tuned for more. So we're nearing the end, and if you were asleep or didn't pay attention at all, this is the slide to wake up on. What do you tell your boss you just saw? Well, if you're creating a skill, we have tens of millions of Alexa multimodal devices that are in market and out to come. And the best way to create a rich interactive experience with those is with the Alexa presentation language. We learned from our customers that more customers interact with their devices if they have a screen. And so in your skill, if you want a skill that essentially goes viral, you should incorporate APL into it. So that way, customers who see and interact with it can learn your skill and want to engage with it more and more. Using APL enables you to bring your own visual brand to your skill. Before, you were kind of restricted to what our Alexa display templates were, but now you can be a little bit more creative and start to create your own personal brand through APL. You can also adapt your skill experience according to the device. So you can utilize when clauses or the viewport to be able to send different documents or show or hide different components on your display. You can also use APL to build unique multimodal experiences that effectively utilizes VUI and GUI at the same time. But then all of this is formulated along the lines of we want to build a community behind APL. So we took a stab at it. Amazon, though, can only do so much. We want our indie devs to be able to help us carry this to fruition. And so we saw with Steve, he made something really cool called info circles. We're hoping that essentially a community will form behind APL, so that way we can build some really awesome experiences and components that we can share across different mediums. So if you're interested in finding out more information beyond what you saw today, there are APL tech documents. We also have a design guide that Jamie wrote that kind of just shows you a little bit more how to marry your VUI and GUI together in an effective way. The APL authoring tool is accessible. You don't actually have to have a skill to start creating things. So if you just want to make some cool screen experiences, you can go directly to that URL. And then finally, we have a lot of different GitHub tutorials. They currently live on Alexa Labs because we are in public beta, but we're going to try and build these out more and more. We have examples right now in Node.js and Java with Python to come. Very exciting. But for APL, again, it's all within the directive. It's the same JSON, so you don't actually need to utilize an SDK to be able to push your APL document. Finally, if you're interested in more, we have a repeat of this breakout session. If you were asleep, you can totally go to that and listen there. So that is going to be, that's not on this slide. Yes, it is. That is tomorrow at 7 p.m. Yes. We also have everything you wanted to know about developing for voice using Alexa. That is going to be tomorrow at 8:30. And then finally, we have our chief evangelist, Dave. He's going to give a year in review of Alexa tomorrow as well. That'll be one that you don't want to miss. Essentially, if you don't go to any other Alexa sessions, go to this one because you'll get an all-up summary of what Alexa has. Finally, we have a challenge with multimodal. We want to really push our customers to create skills with APL because, again, we see, or rather our developers, because we see high customer engagement and interaction with our skills that feature APL. So if you want to participate in our challenge, there are $150,000 in total in prizes. So if you go to alexa.design/multimodal challenge, you can find out more about what it takes to enter that challenge and submit a skill in APL. As of last week, we are certifying skills in APL, so you can start developing right now. And that's it. Thank you guys so much for coming.